And so because of that, if you actually run IOStat and you see constant write activity, something is broken. Something is wrong. Things didn't suddenly decide to get fast. It's broken. Okay? If you must, since I know everyone will hear this and will continue to use IOStat as you always have, if you must, what I would ask that you do is open 2 windows, because you have a big screen, I know. 2 windows, and in one of them run IOStat once per second, and another one run the FSstat. And if you've never used FSstat, this is the tool you've always wanted and didn't even realize was there. Okay? It will be an epiphany moment for you when you run it for the first time. Run FSstat in one window, run IOStat in the other. And what you're going to be able to see is FSstat's going to show you what's going on in the virtual file system, what's going on between your application and ZFS. And IOStat's going to show you what's going on between ZFS and the disk. Okay? This will give you a very good idea of what's actually sort of going on and will be extremely informative. Now, there's one other thing in here that can throw a kink in the works, and that is the ZFS write throttle. Yes, there is a write throttle. Is there anyone here who did not know that ZFS had a write throttle? This is a very smart crowd. ZFS does, in fact, have a write throttle. It will delay processes by sleeping at 1 tick if it thinks that a process is being overzealous and is over-consuming disk. If it's growing the in-memory buffers, waiting to go out to these transaction flushes, and it seems to be over-capitalizing, it will try and kind of level the playing field by slowing that process down so that other processes continue to get in there. It is tunable and it can be disabled, and there are cases where you will want to do that. For instance, if you're running a very large database server and the only thing running on that box is your database, you don't want it to slow down. Yes, it's a hog. Yes, it's doing a lot of I/O. I know. Let it. Now, if you do leave it enabled, it does provide one little kind of benefit, especially in a largely multi-user environment. If you wanted to figure out who's consuming too much I/O and you're not sure who it is, you can detrace the write throttle, DSL pool sync, and you can figure out who's actually doing it, which is really kind of handy. You can see who the hog is. In a lot of cases, like I said, when you do that, you're probably going to find that the hog is the one thing that you want to run as fast as it possibly can, and you may consider turning it off. This is a really fun place to spend a lot of time because actually ZFS has gotten more and more intelligent in the way that it classifies I/O coming through the pipeline, and so it has a lot of metrics actually. It actually calculates throughput. You'll never know it unless you look at its numbers. It's all being kept in its brain, and with dtrace you can put an ice pick in there and pull it out. Yes, sir?
Are these tunables system-wide or file system specific?
System-wide. System-wide. One thing to know about the tunables too, some of the parameters are dynamic, but very few of them. Most of them require that are initialized at the time of import. You don't necessarily, that means that you don't actually necessarily need to reboot the system for it, but you do need to export the pool and import the pool. In most cases, it's easier just to reboot the system. In fact, you see this as a general trend throughout Solaris these days. There are a number of things that can be kind of tuned on the fly, but you need to restart subsystems in order to do it, and it's faster on most modern hardware. So you're all sysadmins. Not me. All right, so backup architecture. Today's data loads are getting too big for traditional weekly fulls and daily incrementals, right? And a lot of you guys are old school, right? You're very old school. You all had a microvax in your bedroom. You know, your parents told you to go to sleep, but you were under the covers with the blanket pulled over, you know, on your Vax box. I understand. But a lot of us aren't using tape anymore, and I hope you're not using tape anymore because it's horrible and evil. And if you're not, and you're going disk to disk, the full and inkers really, to tape, have really kind of determined tape rotation, right? So we have this tape rotation, and that's kind of why we do fulls and inkers, right? To try and keep all these tapes moving around, going, you know, in and out of Iron Mountain and back to you and all this. And it doesn't make any sense, really, when you're doing disk to disk backup. It's different, so don't be old assumptions. Stop treating disk to disk like tape. And so the way I tend to look at backup is that what it really is, it's an exercise in asynchronous replication. Really slow, really sucky asynchronous replication. And so the backup software that I've implemented at Joint were all ZFS, and of course there are very few ZFS options that really take advantage of it, so we had to write our own in-house, is I really picked up the near continuous data protection kind of ideology, and that's how I look at things. Instead of replicating every transaction, I'm replicating, you know, change over the course of 5 minutes, 10 minutes, an hour, or whatnot. And you just keep snapshots rolling around, and it's really awesome. People love rsync. I don't know what it is with rsync, but people love rsync. It's extremely useful for non-ZFS clients, but of course the big problem with rsync, right, is it's slow startup. Once it gets data moving, it's nice, right? But you got to wait, especially if you're doing incrementals. So that startup time can really be a killer. One of the ways that we have used it is in places where I needed a backup system for non-Solaris, non-ZFS systems, but you know, I'm at a startup, so I can't afford like real backup software, right? Is that we would take like a Thumper or something like that, set it up with ZFS. We would rsync the system data out of BSD systems or whatever into a ZFS data set, and then once the rsync had completed, snapshot it in ZFS. And then the next day we would rsync it and snapshot it. And you have this like really kind of nice, do-it-yourself, at-home maker sort of, ghetto backup system that actually works incredibly well. But for proper consistency, if you do have to go and rsync out, rsync data out of ZFS, please make a snapshot and then rsync the snapshot contents out so that it's consistent. It can do it, take advantage of it, particularly if you're dealing with database logs and things like that where you want consistency. So the right way to send to backup ZFS is via send receive. And so this is snapshot replication, right? The beauty of it is that there is no startup lag, like rsync. So as soon as you start it, it starts sending data. Data is moving along. I've heard several people try to argue with me and tell me that rsync is faster than ZFS send receive. And I've done a number of tests, and in every single test, I found that ZFS send receive is on average 40% faster than rsync in any situation. And if you think that it's faster, please provide me with real numbers, because if I'm wrong, I will love to apologize and fall down on my knees weeping and crying. There were large performance improvements that were added in Nevada 105, and we keep seeing efficiencies added to the process to get it faster. Block replication of the entire pool. So some people still like the old school idea of just backing up the raw block device and forget what's on top. ZFS, UFS, who cares? Just replicate all the blocks, and the storage tech availability suite can kind of do that for you. SNDR, which is like what the storage tech, Sun, Solaris network data replication, can replicate the pool out for you to another place. It's cool, except for the fact that you can't actually import a pool read-only, because it's going to update the Uber block when you import it. You may not actually touch any of the files that you're actually interested in, but the pool during the import actually is going to do a small amount of I/O to the Uber block. For that reason, it will break that replication, and then you have to resync, and it's a giant flaming pile of data. It's not worth the trouble. The same goes for other, kind of similar block level replication tools, if you can afford them. So, NDMP. Who is a big fan of NDMP?
Not that I'm a fan, but I use it.
Really? I love NDMP. NDMP is awesome. So NDMP is fantastic, particularly if you can afford the software. NDMP copy is been ported to Solaris and works very well with it, so you can get that as part of the testing toolkit, and I think it's a very big win. The Solaris implementation is actually really cool because it will snapshot the data set before it actually does the data transfer, and then it'll release it behind.